Now that you understand how distributions work, let's move on with our particle system. The next thing I'm going to do is jump down to our initial size module. Let's expand start size. And currently this is set to a distribution of vector uniform, which will give us a min and max value for x, y, and z. Let's go ahead and expand both of these. It is kind of interesting to note, or at least important to note, that min and max are listed alphabetically. So the min is going to be at the bottom, the max is going to be at the top. And you shouldn't get the two confused. Now currently these are both set to 25. We'll go ahead and leave them at the defaults for now, but if you'd like to change the size of your flames when they're first born, this is where you're going to do it. Now down from here we have the initial velocity of our flames. Let's play with this a little bit. I'm going to take our start velocity and expand that. That's going to have a vector uniform by default, so let's expand min and max. We'll scroll down a little bit so we can see all these. For the minimum, we're going to set values of -20, -20, and 75. For the max, we're going to set values of +20, +20, and 125. So our flames are generally moving up, but they've got some left and right variation. That's essentially what we've just defined. Now moving on from here, we've got a color over life module that's here by default. So let's take a look at this. I'll go ahead and expand color over life. Now currently its distribution is set to vector constant curve. What I'm going to do is replace that with just a regular vector constant. The material that we've set up already has the flame color that I want to use. So I'm going to come over to the distribution, click on the little blue arrow, and just choose distribution vector constant. And we're going to set the constant value to 1, 1, and 1. So we're just going to basically use that default color that's already applied in the material. Now down from here we have the alpha over life as well. So let's close up color over life. We'll expand alpha over life. This also has a distribution of float constant curve. And what alpha is going to do is allow us to make our particles fade out. Now they're already fading out just a little bit. If we expand the float constant curve, we can take a look at its points. And it has 2 points. And it's important that you see how to read these. So let's go ahead and expand these out. You have 2 values on a curve point. You have an in value and you have an out value. The in value is the time along the life of the particle, or the life of the emitter as it may be, that the value takes place, and the out value is literally what your value is. So in this case, we're starting off at the birth of our particle, which is time index 0, and we have an alpha value of 1, which is completely opaque. Now take a look at our second point. We're saying at an in value of 1, which is the end of our particle's life, we have an out value of 0, meaning we're fading out over time. So we start off at birth, fully opaque, we end up at death, fading away. And we can see that result in our preview window. What I'm going to do is actually graph this out so we can see the result. Let me go ahead and just kind of pull this up a little bit. Over here on our color over life module in the emitter list, at the far end there's a little tiny green icon that looks like a curve. If you click that, you can see the result over here inside the curve editor. And I'm going to scroll back on the mouse wheel to make it a little easier to see. And you can see how we're just dropping off in our opacity as time marches forward. We're going to change this a little bit. Let's start off by adding another point. So over here inside our points list, in the properties, if you look all the way over on the right hand side, you'll see a little green arrow labeled Add New Item. Let's go ahead and click that, and now we have a third point. Now that's going to break our particle system. It's going to start to behave really strangely, and the reason is that our last point in the curve has an in value of 0, which is the birth of our particle system, or the birth of our particle, and it has an out value of 0 too. So it's kind of like we're defining the birth twice. We're saying in the first point that at birth I want you to be full bright, and then in the third one we're saying at birth I want you to be dark, and it really starts to make things confused. But we'll set it up one point at a time. So come up to point 0, set the in value to 0, set the out value to 0 as well. Let's come down to point 1. We're going to set the in value to point 2, or 20% of the particle's total lifespan, and the out value to 1, or full bright. And now if we come all the way down to point 2, we're going to set the in value to 1 or the death of the particle, and we'll leave the out value at 0. Now what we've just done is we've caused the particles at the base of our flame to now fade into existence over the first 20% of the particle's life. They no longer pop into view. And you can see that reflected here in our curve editor. We ramp up and we ramp back down. Now this is a really harsh curve. You may want to make this linear. We could select our second point here in the curve editor and switch over to, say, curve auto clamped. And we could probably do the same here for the first one as well. So we click that and do curve auto, and now we have a nice flowing curvature. Though, granted, these particles are moving so quickly that the audience members wouldn't really be able to tell that linear change. So there's a quick look at setting up our color. Now, the last thing we're going to do in this video is set up our sub-image index, which will allow us to switch between our different pictures of flame that we have inside of our material. So I'm just going to right-click here inside the emitter list within our emitter. We'll come down to sub-UV, and I'll just add a sub-image index. And as soon as we add that, we immediately start to get a random variation of the different sub-images flickering through. Now that's as far as I want to take things from here, so I'm going to go ahead and close Cascade for now. Let's make sure that we save our package, and that will wrap things up for this video. Thanks a lot.